Now we will look at some basic differentiation rules, in particular the power rule. This will really help us out. It will make differentiation a lot easier. So first of all, we're going to look at the constant rule. The constant rule just says the derivative of a constant is zero. And that makes a lot of sense if you think about it in terms of slope, which derivatives are. So if I said, what's the derivative of 6? So if I said, what is the derivative of the number 6? Well, you have to remember, you're not really taking the derivative of a number. You're taking the derivative of this function y equals 6. Y equals 6, as you know, is a horizontal line at 6. So this is what the function looks like. The derivative just says, what is its slope? Well, the slope of a horizontal line at every value of x is 0. Therefore, the derivative slope is 0. The next rule that we really don't have a theorem about, but I want to show it anyhow, is what if we had something like the derivative of 3x? You can probably guess what that derivative is going to be because we know derivatives are slopes. So again, we're going to think of this as the function y equals 3x. We're going to think about what that function looks like, and it's a line with the slope up 3 over 1. So just kind of like the problem above, the slope at every point on this graph is 3. Therefore, it doesn't matter what value of x you put in, the slope of 3x is always 3. So these are very easy examples of functions you can take the derivative of, and you don't have to plug it into the limit definition. Now the big one is the power rule. This takes those and expands on them. The power rule says the derivative of x to any power. It says if n's a rational number, this power rule says rational number, but we'll find out that it could be irrational as well, is n times x to the n minus 1. In other words, you just bring down that exponent and then raise x to 1 less than it. That's it. But here's what makes differentiation hard. Taking the derivative of x to a power is fine. We have a good rule now, but that doesn't fit a lot of different functions, as you'll see. So we'll start out like this. We have 1, 2, 3, 4, 5 questions, and we're going to take the derivative of all 5. If you're watching this on video, I'm not going to pause between them, but if I were you, I would pause between them, try to do them before I do it. So I'm going to begin. According to the definition of derivative here, y prime, or that's the power rule, would be 3x to 3 minus 2, which is, or 3 minus 1, sorry, which is 2. This next one, you're going to have to rewrite it first. So if you haven't thought to do that, and then pause and try it yourself. So that's the rewriting part, and that's going to be a common theme in derivatives. A lot of times you're going to have to rewrite. According to the power rule, this would be 1/4 times x to the 1/4 minus 1. Now, you're going to get very, very used to subtracting 1. do not use a calculator on these. Just get used to subtracting 1 so you can do it by second nature. So it's 1/4 minus 1, which is 1/4 minus 4/4, which would be negative 3/4. I'm going to get really good at doing that because you're going to be doing that very, very often. Now we're going to simplify this because if you have a negative exponent, it's not simplified. So we bring it down to the bottom. And that's the derivative. Now, sometimes they'll simplify it back into a radical form. You do not have to do that, but since it started in radical form, a lot of times you'll see it simplified back into radical form. But either one of these answers is okay. The next one, you have to remember your rules of exponents, just like the last one. This is x to the 3/7. So the derivative would be 3/7 x to the 3/7 minus 1, so minus 7/7. Simplify. And you're done. Next one. Now, try this one before I do it. So the common mistake for this one is I see this x cubed, so we just apply the power rule right away. But you can't. You have to apply the power rule exactly how it's shown. So it only takes the derivative of x to the n. That's it for now. So you have to make this x to a power, not 1 over x to a power. So your rewriting should come like this first. Now, you can apply the power rule. So you bring down the derivative would be negative 3 x to the negative 3 minus 1, which is negative 4, which is negative 3 over x to the positive 4. So the next one is going to be very similar. So for the last one, you're going to rewrite apply the power rule, negative 1/2 x to the negative 3/2, simplify, and there you go. So a common theme you're going to see with derivatives are these. Rewrite, differentiate, simplify. This is the only calculus you're doing, the differentiate part, the derivative part. That's usually the easiest part. Rewriting, you have to remember to do. Simplifying, sometimes that becomes annoying, but that's what you're going to have to go through. So like this was the rewrite part. So we could take the derivative. This was the derivative part. And this was the simplify part. So that's how you find the derivative of x to any power. So we know a lot of functions are not like that. So we're going to have to come up with new rules and properties and theorems to be able to differentiate more complicated expressions. Stay tuned to the next video.